So now we're going to work with angles that are multiples of pi over 4. We've lost a couple of pi's, so I'm just going to fill those in. You can kind of see where I did that. Sorry about that. Again, that's something that happens in the communication between the PDF and the Dropbox and the Explain Everything. So I've got this going on. Pi over 4, again, remember that half of the circle is pi in radians. So pi over 4, if we want to divide the circle into 8 congruent arcs, well, basically we can divide, oh, that doesn't look good. Let me do that again. We can divide each quarter of the circle into slices like this, and we wind up dividing it into 8 equal pieces. And each of these is going to be another pi over 4. So here's pi over 4. This one is 2 pi over 4. Here's 3 pi over 4. 4 pi over 4. This one's 5 pi over 4. 6 pi over 4. 7 pi over 4. And this turns into 8 pi over 4. Now you notice that some of these can actually be reduced down. So for example, 2 pi over 4 really becomes pi over 2. 4 pi over 4, if you reduce that, you get pi. 6 pi over 4 reduces to 3 pi over 2. 8 pi over 4 reduces down to 2 pi, which is one full circle around in radians. So I've got this circle, and it's essentially broken down into 8 equal slices, and they're all sort of a radius of pi over 4. Now, let's talk about what's going on here. When we talk about it being a pi over 4 angle, we're actually talking about moving this direction by pi over 4. So the angle that's pi over 4 is this guy right in there. That's pi over 4. I have moved from the initial side, laying along the positive x-axis, and I've kind of rotated the terminal side up by pi over 4. We have done changing back and forth between radians and degrees, and if you know how you do that, pi over 4 times, bring in the degrees, divide out the radians, you wind up with 45 degrees. So this little dot right here, that's a 45-degree angle. Keep that in mind, because what I'm about to do is going to take advantage of that. I'm going to take away this little arrow there, and I'm going to take that away, and we're going to look at this. Because what we want to do is we want to find this point right there, that blue point. That's what we want. So the way we've been doing this before, right, is we looked at what was the y-coordinate there and what was the x-coordinate there. So if I can figure out that distance, I've got my x-coordinate, and if I can figure out this distance, I've got my y-coordinate. That's great. But again, let's look back at that. So unit circle, again, remember, has a radius of 1. Radius is always 1, no matter what. From the center to any point on the circle is 1. That's very helpful. This will be a 45-degree angle, and there's a 45-degree angle up at the top there. So this is a 45, 45, 90 triangle. And I'm not going to go into the whole thing with how to reconcile a 45, 45, 90 triangle or how to find the different sides, because you did learn that last year in geometry. I will, on the little sheet that has the link to this video and the other videos for today, I will also put some links to helpful things that might explain the 45, 45, 90s and the 30, 60, 90 triangles, so that if you need to refresh your memory, you can go back and do it. But I'm here to tell you right now that if the hypotenuse is 1, that means that each of the two sides has to be root 2 over 2. That has to be the length of the two sides. Which means that my x is root 2 over 2, and my length for y is root 2 over 2. And again, that pretty much means that this point right here is going to be root 2 over 2 for the x distance, and root 2 over 2 for the y distance. That's what I'm going to have there. Now, one thing that, and again, so summing up again, we've got a nice little 45-degree angle right in here because we've Move the terminal side of the angle pi over 4. You can draw in a little 45, 45, 90 triangle. And if you want the x-coordinate for the point where that terminal side hits the end of the unit circle, you can use what you know about 45, 45, 90 triangles to find the length of the two sides, and that's your terminal point. That's how you're doing that. So, problem C3 basically said, draw in a right triangle with pi over 4 for one side. On the positive, what kind of special right triangle is it? Oh yeah, 45, 45, 90. Label the sides of it. We did that. Find the terminal point. That's the root 2 over 2 and the root 2 over 2. Now, I need to see if I'm correct. Let me see if I can slide this at all. Apparently I cannot. So hold on just a moment. Okay, I'm going to hike this up a little bit so we can see the rest of it. So, show that the terminal point satisfies the equation x squared plus y squared equals 1. Okay, this is back to what we were doing on Friday. So, my x was root 2 over 2. My y was also root 2 over 2. I will take the square of each, add them together, and I'm going to see if I get 1. So, root 2 squared is 2. And 2 squared is 4. And I'll get the same thing over here. That's 4 over 4, which is indeed 1. So root 2 over 2 and root 2 over 2, that point with those as the xy's, it's on the unit circle. It's fantastic. So now, remember what happened when we started going around the circle. And again, we've lost some pi's, so I'm going to fill these in. And pi over 4. So you'll notice in this little chart we're going with pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So I am going to pull back so that we can see back to here again. And you'll notice that the pi over 4 is in the first quadrant, and the 3 pi over 4 is in the second, and the 5 pi over 4 is in the third, and the 7 pi over 4 is in the fourth. And remember how we did on Friday. We realized that if you're the same distance away, then you wind up with the same numbers. So what's going to happen is I'm going to have some variation of root 2 over 2 comma root 2 over 2 as the point for all of these. But what's going to change is, because in every quadrant it's a different it's different in terms of positive and negative. So first quadrant, x's are positive, y's are positive. Second quadrant, x's are negative, y's are positive. Third quadrant, everybody's negative. And the fourth quadrant, the x's are positive and the y's are negative. So here's the cool thing about this, the seriously cool thing about this, is if I go around the quadrant, I'm still using root 2 over 2 comma root 2 over 2. I'm doing that every single time. All that's going to change is the signs. So, if I want to pull this up, and I'm going to take a look at this little chart, pi over 4, remember we wound up with both positive because I'm in first quadrant. So this is in quadrant 1. This one's in quadrant 2, which means that the x will be negative and the y will be positive. This one's in quadrant 3. And that means that, well, they're both negative. Negative root 2 over 2, negative root 2 over 2. And then we get to this last one, which is in quadrant 4, where the x is positive, but the y is negative. So that's what you've got. It's the same set of numbers for each one of these points. That's pi over 4. They just changed their signs because of how we're going around. And this last question, C6, why do we skip 2 pi over 4, 4 pi over 4? We kind of went through that before. This one reduces down to pi over 2. That reduces to pi. This reduces to 3 pi over 2. And that last one reduces to 2 pi. So we already actually know what all of those, what the terminal points for all of those are. We just did that. Pi over 2 has a terminal point of 0, 1. Pi is negative 1, 0. 3 pi over 2 is 0, negative 1. And when I come back to 2 pi again, I'm at 1, 0. So I've already got those points on there. So there we are. This is it. This is the lovely pi over 4s of the unit circle. Again, if you're having trouble remembering your 45, 45, 90 triangles, I'm going to put another link in for you so that you can look that up. Now, we're going to move on to the pi over 3's and the pi over 6's, and you know what? They're going to work almost the same way.